Today we'll be measuring Ethernet cables with the MOHR CT100B TDR. Let's get started. Always remember to properly discharge static before connecting to any high-frequency test equipment, and never connect to live equipment. In this video, we're going to be looking at twisted pairs in Ethernet cable. These cables will follow the T568B standard using the RJ45 plug. We'll be using the MOHR CT100AK ETH Ethernet adapter kit. For M12 Ethernet cables, we recommend using a properly pinned adapter with the MOHR Ethernet adapter kit and not our pin and socket set. The MOHR Ethernet adapter has 4 ports representing 4 pairs of wire and an RJ45 jack. Included in the package is the BNC connection cable and an SMA adapter. Before we take our first measurement, let's take a look at how Ethernet cable is constructed. I've opened the outer jacket to see inside this first sample. You can see this cable contains 4 sets of twisted pairs. Each pair has its own twist density and may differ from cable to cable and manufacturer to manufacturer. This particular cable has 5 twists per inch for the orange pair, 3.5 twists per inch for the blue pair, 3 twists per inch for the green pair, and 2.5 twists per inch for the brown pair. Twisting of copper lines dates back to when telephone lines were first deployed alongside power lines. Alexander Graham Bell, known as the inventor of the telephone, was the first person to twist copper pairs to reduce crosstalk between the lines. Twisting the copper pairs allowed for the reduction of electromagnetic interference and an increase in range. Ethernet copper cables adopted the same technique to reduce crosstalk between internal wires as well as external wires. To use the Ethernet adapter kit, plug the cable to be tested into the RJ45 jack. Next, connect the BNC cable to the desired port representing the colored pair to be tested. After properly discharging static, connect to the CT100B. For this video, I've placed one cursor at the beginning of the cable being tested where the adapter ends and one near the end of the cable. To locate the end of the adapter, look where the impedance first spikes. Unplugging and plugging the cable from the RJ45 jack will confirm the location. Going to scan and save this trace by first pressing scan, followed by start scan, then press save. Using an attached USB keyboard, I'm naming this one 86OR, and I'll repeat the process with the other 3 pairs, naming them 86BL, 86GR, and 86BR, representing the 86-inch cable and the color of the pair being tested for this video. What we have now is all 4 traces on the screen, and they are all different lengths. Keep in mind this is due to the different twist densities of the pairs within the cable, and their electrical lengths will vary based on their twist density. This is also referred to as skew. Getting a better look in CT Viewer, placing one cursor where the cable connects to the adapter, and then I'll zoom in to show the end of the cable. I've colored them to show what each trace represents within the cable, and I have them all measured with the same VP. As you can see, the delta measurement changes the time and distance as I tab from cable to cable. This is due to the TDR measuring in time. All other factors are based off of the other variables input by the operator. Now I'm lining up all the traces to match the same connection points, and have also changed the VP of each pair. Jumping to the other cursor I placed at the end, you can see that they are all now roughly the same length, and when I tab between pairs, the delta length stays the same, and the time and the VP are the variables that are changing. Also notice the higher the twist density, the lower the VP. Taking a look at a much longer cable, 33 meters according to the manufacturer's stamps on the side. After scanning each pair, you can see that each pair has a different electrical length and not the same as the previous 86-inch cable. As I've measured these cables for this video and previous videos, different manufacturers will have different build specifications. And in practice, you should expect variation from product to product and even lot to lot. For more information on finding the VP of a cable, see our distance to cable fault video linked here. In CT Viewer, jumping to the end of the cable, and like before, the length and time change while the VP stays the same. And now showing where all the VPs have been assigned to each pair within the cable. The cable length stays the same while the VP and time changes. And there you have it, Ethernet measurements on the MOHR CT100B TDR. Be sure to like and subscribe to our channel for more updates. If you have any questions, check out our website at mohrtm.com. That's MOHRTM.com. Give us a call or shoot us an email. Thanks for watching, and we'll see you next time.